This video is an introduction to the concept of acid and base in chemistry. We are going to look at the basis of acid and base in chemistry. Alright, so let's begin with definition. Now, Linus defined acid, which is the general definition of an acid, as a substance that can dissolve in water to produce a hydrogen ion as the only positive ion. Also, Lowry defined acid as a substance that can donate a proton, that's a hydrogen ion, whereas Lewis, also a scientist, defined an acid as a compound that can accept a lone pair of electrons to form a coordinate bond. Alright, so basically we have two classes of acid. Alright, so we have the strong acid and the weak acid. Now, a strong acid is simply an acid that can ionize completely in water. A typical example, we have tetraoxosulfuric acid, we have hydrochloric acid, we have nitrous 5 acid. So these are examples of strong acid. We also have a weak acid, an acid that can ionize partially in water. Alright, so the ionization of this kind of acid is not complete. Typical examples, we have our tetraoxophosphate 5 acid. We also have our triazocarbonate 4 acid. We also have our ethanoic acid CH3COOH and the rest of them. These are examples of weak acids. Also, acid can be monoprotic or polyprotic. Monoprotic acid are those acids capable of donating only one proton. For instance, hydrochloric acid is a monoprotic acid, can only donate one proton or hydrogen ion. Another example is this acid, triazonitrate 5 acid, is a monoprotic acid, can only donate one proton or hydrogen ion. Whereas polyprotic acid are those acids capable of donating more than one proton or hydrogen ion. Typical example, we have tetraoxophosphoric acid, so you can donate more than one proton or hydrogen ion. Also have tetraoxophosphate 5 acid and also this one triazocarbonate 4 acid. So these are examples of polyprotic acid. Alright. Now, acids also have well-known properties such as the ability to have a sour taste. Acids also can be corrosive when they are concentrated. Alright, so having known these basic concepts about acid, let's watch this and look at the concept of base. Alright, let's look at alkalis or base. Okay, now a base, according to Linus, which is the general definition of a base, he defined a base as a substance that can dissolve in water to produce a hydroxyl ion as the only negative ion. Alright. Also, in the view of Lowry, he defined a base as a substance capable of accepting a proton or hydrogen ion, whereas Lewis defined a base as a compound that can donate a lone pair of electrons to form a coordinate bond. Alright, so having known this basic definition of a base, let's look at classes of a base. Just like acid, we also have strong bases and weak base. Alright, so example of a strong base. A strong base is a base that can ionize completely. What example have potassium hydroxide, we have sodium hydroxide, we have calcium hydroxide, we have barium hydroxide. So these are examples of strong bases. We also have weak bases, those bases that ionize partially and incompletely in water. Simple example, have our ammonia. Alright, so ammonia is an example of a weak base. We also have magnesium oxide. Alright, so this can serve as a weak base. Now note that oxides of metals are alkaline in nature. Alright, so they are bases in nature. This is it for strong bases and weak bases. Also, Bases also have well-known properties such as the ability to have a beta test, the ability to be soapy in nature, and they can be corrosive when concentrated. Alright, so concentrated bases are corrosive in nature. Alright, so before we end this video as an introductory video, let's look at a concept in acid and base known as conjugate acid and base. So let's look at this concept. Let's wipe this. Okay, so the concept of conjugate base and acid in chemistry. Alright, so basically a conjugate acid is a base that a proton or hydrogen ion is added to, whereas a conjugate base is an acid a proton or hydrogen ion is removed from. For instance, let's say we have this reaction, hydrochloric acid reacts with ammonia, alright, to give ammonium ion, alright, plus chlorine ion. So this will be the conjugate acid, whereas this will be the conjugate base. This is the base and this is the acid. So a conjugate acid is a base that a proton or hydrogen ion is added to. So if you check here, this base in this original form is having 3 atoms of hydrogen, but when it reacted with this, when this base reacted with this hydrochloric acid, it gained this hydrogen ion or proton to now become a 4 atoms of hydrogen, right, in it. Whereas this is the conjugate acid, whereas in this conjugate base, this acid that reacted with this ammonia lost this hydrogen ion and formed only this new anion, this chlorine ion. Alright, so this is the conjugate base. Alright, now note that when, like in this reaction, when an acid combines with a conjugate base, we have a conjugate pair. Alright, whereas when a base combines with a conjugate acid, we also have a conjugate pair. Alright, so take note of these concepts. Alright, let me recap once more. A conjugate acid is a base that a proton or hydrogen ion is added to, whereas a conjugate base is an acid that a proton or hydrogen ion is removed from. Alright, so guys, this is the basis of acid and base in chemistry. This is an introductory video, and with this we have come to the end of the class. Hope you learned something interesting. If you are new to the channel, be sure to subscribe for more videos. So like, share, and comment on this video to me how you feel what you have learned. If you seem to have any specific questions, feel free to leave your question in the comment section below, and I'll be sure to give you a response. That's it for this class, guys. Thanks for watching.